welcome to my channel, wherever it is you're watching this from, be it YouTube, Twitter, or Upwork, or Kaggle, or GitHub. Wherever you got this video from, I welcome you. So I'm going to be demonstrating the AI calculator I made. Yes, you heard that right. This is an artificial intelligence calculator. Normally, when programmers make a calculator application, they just use the usual mathematical library to make those calculators to work. But I took a different approach in this case. Instead of using the usual math library to make calculations, what I did was to train an AI using machine learning technique for addition, subtraction, multiplication, and division. So there's a set of for instance, let's demonstrate it and see how this works. Now let's try 8 plus 8. We all know 8 plus 8 is 16. Now it's giving us 15.99. So this is the prediction that was made by the AI. 8 plus 8, it made a prediction that is 15.99988. So it doesn't use a mathematical library to make those calculations as you would expect from a normal calculator. Now let's try something else. Now this 15.999, I'm coming. Okay, let me clear this. Now let's say 16, or let's say 100 minus 50. We know that's 50, right? Now you say 49.999956. That's also a prediction made by the artificial intelligence. I didn't use the usual mathematical library to code my application. Now let's try something else. Now let's try the multiplication. Let's try a simple. Okay, now let's try 3 times, let's say 3 times 4, that's 12. Now it gave us 13.59. That was the prediction by the AI. It wasn't, I didn't use a mathematical library to code that. It was a prediction made by the AI. Okay, let's try something else. Let's try division. Now let's try 15 divided by 5, which is meant to be 3. Okay, so that one is way off. That's way off. That is way off. Let's try another division. Let's try 60 divided by 2, which should give us 30. Okay, that one is close. You can see that it's getting some predictions correctly, some predictions wrong. 30, which is very close enough. Now let's try something else again. Let's try something else. Now let's try 90 divided by 3. 90 divided by 3 should be 30. Okay, it gave us 20 instead of 30. At least it got some of the predictions correctly, but not everything. So the whole point of this AI calculator is just to show the power of artificial intelligence, how they actually work behind, and how you can actually use it to make pretty accurate prediction. But I noticed something. The plus and subtraction seem to be the most accurate, no matter how large the value is. Let's try a really large value, like let's say 5,000. 5,000 minus 50 should be 4,950. 4,000. That was very close. That was very close. Now let's try a really large number. Now these numbers that I'm trying out were not in the training data of this AI. Let's try 8,000 plus let's say plus 350. That should be 8,350. 8,003. That was very close. So addition and subtraction seem to be really good, but division, sometimes it gets division, sometimes it doesn't get it. Let's try 900 divided by 30. 900 divided by 30, that's 30. Well, that's actually correct. Yes, that's actually correct. So you see, sometimes it gets it, sometimes it just doesn't get it. You can see that Let's try something else. When I tried 60 divided by 3, you can see that this is a little bit off. Some of the results are off, some of the results are not so good. So let's see what's happening now. Let's open the training data for addition. For instance, this is the training data for addition. You can see value 1, value 2, and the results for addition. Normally if you add this plus this, you get this plus this, you get this plus this, you get this. So value 1 and value 2 are the features, while results is the label, what you're trying to predict in the AI calculator. So this is this is just a regression, is a supervised learning under regression. The same thing for division. Okay, let's check subtraction. For subtraction, the same thing, value 1, value 2, those are the features, and result is the label, what you're trying to predict. So this is just a simple regression under supervised learning. You can see that's how what I use to train data. I just generated random numbers using Excel rand between function. And for division, there's something about this division that is not making it get some results accurately, and some what I just did was that I generated numbers from 1000 all the way down to 1, and then I randomized numbers between 1 and 20. Yes, I randomized numbers between 1 and 20, and then I reversed it also, and then I reversed too, and then I did it again, randomized between 20 to I think to 40 or thereabout, and then I reversed it also. So that's basically, so the training data is from 1 to 40 and from 100 to 1 on its division. So it might not have seen enough of some certain calculation. For some reasons it doesn't get some divisions correctly. And from multiplication actually has a lower training data set, because I didn't want it to be getting too large values for the results. Now let's try some other multiplication and see how this goes. Now let's try another multiplication that is, so 9 times 9, for instance. 9 times 9 is 81. Okay, that's very good, that's very close. 9 times 9 is 81. What about 8 times 8? 8 times 8 is 64. Okay, that was off, 72 instead of 64. Now what about 5 times 5? 5 times 5 should be 25. That it gave us 22 instead of 25. Not bad. What about 0? Now I wanted to try something. What if I try 9 divided by 0? 9 divided by 0 should be infinity, should be a very large number. What is it going to say? It give us 10. You see now? You see that it's not actually, if I use the mathematical library, it will have given me infinity. It will have written the infinity symbol from me. 9 divided by 0 is not 10, it's infinity. Now what about 0 divided by, what about 0 divided by anything? 0 by 5 should be 0. Okay, 0.4. Okay, now what about 0 multiplied by, let me clear this, 0 multiplied by 6 should be 0. It's giving us 4.9. Okay, probably didn't have enough data on 0, didn't have enough 0 multiplication data, so I'll work on that. What about 8 multiplied by 0 minus 1.0. okay, so this just shows some demonstration of how artificial intelligence can actually work together. And I faced a lot of challenge based on my previous video, the challenges I faced making this application. For instance, I tried to combine all the mathematical operation into the same data set and using a single model input and output for the calculation. That was an epic fail. The AI couldn't get any relationship at all whatsoever. I thought including the label would make the AI understand that, okay, this is for addition, this is for plus, this is for subtraction, this is for multiplication, but I was wrong. I needed to separate each model for the different mathematical operation, and then I used the AutoML to do the hyperparameters and the model selection. It gave me the best model, and I saw the MSE, the mean squared error. I chose the one with the lowest mean squared error. All these hyperparameters you're seeing here was made possible by the AutoML. This is the one that uses multiplication. Light GBN is for multiplication. For division is also light GBN for division, and these are the hyperparameters for it. You can see how high the learning rate is for division. For multiplication, the learning rate not so high, 0.2. And for addition, let's check the one for addition. For addition, it uses this stochastic dual coefficient ascent. Where is it? Yeah, this is it. Stochastic dual coefficient ascent, and these are the hyperparameters for addition. And for subtraction, it uses the same thing, stochastic dual coefficient ascent. Also, they are all regression models. Yes, so these are everything that has been used. So we are going to open the model file now and see how it's different behind. So I'll expect the subtraction and addition model to look alike and the division and multiplication model to look alike, since they are using the same algorithm. So let's get through it. So we are in the folder of the application that was created by Visual Studio. So I'm just going to copy this now. Control C. So I'm just going to copy this now and paste it to my folder and see what we have here. So now we have extracted all the model files itself, so we're about to see what we have here. So this is Netron, what I'll be using to visualize the models. So I'll go to Maths model. Good. Now let's visualize addition model and see what we have. So this is addition model, value 1, value 2 returns the result. This is the first transform. Type, replace transform. Takes in 2 values, outputs 2 values. This is the first concat transform. Takes in value 1, value 2, and it outputs features. So this is the one that featureizes, that creates the features. It featureizes and takes and outputs the features. Then there is where we have our model, our SCDA model. You can see linear regression. It has, you can see the bias, the indices, and the weight of it, and then the schema. And it's a very simple model, it's not even difficult. That's just for addition. I would guess that subtraction would also look the same way. So now let's open something else again. Let's open another model. That's for addition. Let's check subtraction. Now this is for subtraction, value 1, value 2. Same thing, replace transform. Takes in value 1 and value 2 and outputs the features. You can see the weight. It has +1 and -1, +1 and -1, and it has a bias of 0, which actually makes sense for subtraction. For addition is +1 and +1, which is actually true. So this linear regression is just like saying y is equals to x1 plus x2, and the bias of x1 is 1, the bias of x2 is what? Is also 1. If I should change this manually to 1, the weight to 1 1, I'm going to be getting the exact value in my addition, and I should change the bias to 0. I'll be getting exactly 1. I'll be getting the exact calculation in my AI, but it had to figure this out itself. That's what the algorithm does. That's what the SCDA algorithm does. For this, for addition, that's for addition. And for subtraction, you can see, okay, this is still for addition. Now this for subtraction, you can see plus 1 minus 1, which is actually true. It's like saying y is equals to x1 minus x2. x2 here is the value 2, x1 here is the value 1, and the bias of course is 0. So it's actually a very simple model. I wonder what the model of multiplication is going to look like. Now let's find out. So this is multiplication model. Let's open it and see. Okay, so this is multiplication model. Doesn't look as complicated as I would expect it to look. Replace transform also takes in value 1, value 2 output, takes in value 1, value 2 output features. And what about this? Let's see. Oh, okay, light GBN. So this is what it's, this is the model itself. You can see the weight is just 1, LTE child, GT child. This is light GBN, gradient boosting machine. Exactly, just a combination of several weak models. Trees, number of leaves 4, maximum output 0, split features, threshold, just for multiplication. That's what it is. Input and output, input features, output features, number of leaves, maximum. Okay, value of leaves. Yeah, it actually looks simple looking at it this way. So let's open the last one, the division model, and see what it looks like. Okay, so this is the division model. Also the same thing, replace, concat transform, and oh, you can see LT. Okay, the weight is 1 in this case, but for this one the weight is also 1, minus 1, 2, and minus 2 for the LTE child. Minus 1, 2, and minus 2 for multiplication. Division is 1, minus 1, and minus 2. So you can see the little difference is what actually makes it able to know some division and some addition. And this would be is a mixture of different regressions, a mixture of different regressions. Yes, having different values, different weights, different biases, and the rest. So I hope you really enjoyed this illustration of my AI application, and in future, in the nearest future, I'm going to make this square roots, x raised to power y roots x, cos, sine, and tan. I'll also make it predicted by an AI and see how well it performs. So I'll see you guys again in my next video. Do enjoy the rest of your day.